Hi everyone, this video is going to share with you how to find the argument of a complex number. So first of all, I'll introduce you what is the argument of a complex number. Basically, a complex number, it might be fall on our Argand diagram at either the first quadrant or second quadrant or third quadrant or lastly fourth quadrant. So for every complex number, it has its angle formed in between the positive real axis to the complex number. All right, follow the either the direction of anti-clockwise or clockwise direction. So if, let's say, the complex number is 4 on the first quadrant, all right, this is one of the example. If the point that we plot for the complex number is at the first quadrant, then we connect a line to this origin. It forms the Z. All right, it forms the complex number. Now we want to find the angle formed between the real axis, positive real axis to the complex number. This is the angle that we want to find. And this angle is known as the argument of the Z. And we can give the symbol as theta. Normally, the argument of the complex number, we also can give the symbol as a ARG of the Z, which is given as a symbol theta. So now we want to find the theta. How are we going to find the theta? If let's say this point is 2, 1, means that the Z is actually 2 plus I. All right, 1I, 2 plus I. Now we want to find the angle of this 2 plus I. So we might form this as see this as a right angle triangle. All right, where the height of the triangle is 1 unit, because the height is referred to the imaginary part, and the base, the length of the base is 2 unit. So recall back the tangent. All right, tangent, for the tangent theta is actually equals to 1 over 2. So we can want to find the theta. Theta is a arctangent 1 over 2, which is given as a 0.464 radian. Bear in mind that when you want to present your argument, we normally will give the answer in the radian unit and not the degree. For another example, I will show you if the complex number is 4 at the second quadrant, which I draw in a green line. If let's say this point is -1, 2, means the Z is equals to -1 plus 2I, right? So now we want to get the angle formed between the positive real axis to this line is from here. Positive real axis is from here, and we draw an arrow to the line anti-clockwise. Okay, anti-clockwise direction. And this green angle is actually our new theta. All right, our theta, which is we known as the argument of the Z -2 plus 2I. And how are we going to find the theta? So we are going to see this as a right angle triangle, and the height of the right angle triangle is 2 unit, and this is a 1 unit. All right, the base of the right angle triangle is 1 unit. To get the theta, I would like to use the concept of the tangent first to get the alpha. All right, to get the alpha, and I know that alpha plus theta is forming 180 degree. All right, or we say pi radian. To get the theta, we can use pi radian minus alpha. Once we get the alpha, we can take the pi minus alpha. We will get the argument of the Z, which is known as theta. All right, so now let's start to find. Find the alpha first. We know that the alpha is a arctangent 2 over 1. Okay, so we got it as a 1.107 radian. To get the theta, as I have explained just now, the theta, also known as an argument, all right, argument of z, is equals to theta, and we are using the pi minus the alpha, which is a pi minus 1.107 radian. Finally, you have your argument as a 2.034 radian. So again, remind you that we have to give our answer in the radian unit. Another example is if the complex number is 4 at the third quadrant. So as an example, I got a point, -1, -2. This means that my complex number can be written as a z equals to -1 minus 2i. Alright, now I would like to get the argument. So where is the argument? The argument again is the angle fall between the positive real axis to the line. So the positive real axis, we always refer to the right hand side of the real axis. Alright, I'm using the red pen. This is the angle from the positive real axis is over here to the line that we form, to the line of the complex number. So this red angle is actually representing our argument and known as a theta. So to get this angle, I would like to see this as my right angle triangle, and I would like to get the alpha over here. After that, to get the theta, we are using the pi, all right, which is 180 degree, pi radian minus the alpha. We will get the theta. And bear in mind that now the angle is at the follow the direction of a clockwise. All right, when the angle is using the follow the clockwise direction, don't forget that final answer is in the negative sign. All right, now we start to find. Okay, get the alpha first. Alpha is equals to the arctangent. All right, arctangent 2 over 1, because this is the height of the triangle is 2 unit and the base is 1 unit. All right, so we got the 2 1. Now later on, okay, you can simplify it, no problem, or you can just write as a arctangent 2. All right, later on, to get the theta, or we say argument of the z, is we are using the pi minus the answer that we found for the alpha, or we can just write arctangent 2. And don't forget that now the angle is at the clockwise direction. So in front of your answer, you need to put a negative sign to show that this angle you measure follow the clockwise direction. Final answer, you will get negative 2.034 radian. Let's focus at the fourth quadrant now. If the angle, or we say that if the complex number is 4 at the fourth quadrant, where this point, for example, as a 2, -1, all right, so this complex number can be written as a 2 plus negative I, or we say 2 minus I, all right, 2 minus I. Then now we want to get the argument of this z. Okay, again, we recall back the definition of an argument. That is, the angle fall between the positive real axis to the line that we form for the complex number. So this is the one, yeah? Okay, from the positive real axis over here to the line that we have drawn here, this is the angle theta. Okay, again, this theta is measured follow the direction of clockwise. So later on, don't forget the answer must be in negative. All right. Now we can start to find the theta, which is a argument of z equals to theta, and this is equals to, okay, we can see this as our right angle triangle, where the height of the triangle is 1 unit. Okay, the base of the triangle is 2. So this is your arctangent. Theta is arctangent. Opposite over adjacent. That is 1 over 2. Okay. So because of this angle, we measure follow the clockwise direction. So don't forget there, you have to put negative. Yeah, negative for this angle. So the final answer is negative 0.464 radian. All right, thank you. So as a conclusion, if your complex number, which is in the form of a plus bi, z equals to a plus bi, if it is a 4 at the first quadrant, then the argument of the z, or we denote as a theta, is equals to the arctangent modulus of b over a. All right. Then if let's say the complex number is 4 at the second quadrant, the theta is actually using the pi minus arctangent modulus of a b over a. All right. And if let's say at the third quadrant, the angle is measure follow the direction of the clockwise, which is from the positive real axis to the line. Then don't forget the answer must be in negative. Negative over pi minus arctangent modulus of a b over a. All right. And if let's say for the fourth quadrant, then your argument theta is equals to negative of a tangent, arctangent, modulus of a b over a. All right. Thank you for watching.